All right, good morning, everyone. This project, we're doing a real-time tweet imitation. This presentation will go over some background information and motivation, some major NLP techniques we used, also some related studies. We'll also have a demo to show you some of the outputs and discuss some challenges we faced and future improvements we may have. And finally, any questions if you have any. Right, so in the real world scenario where there are a lot of famous people, they tend to have thousands and millions of followers on social media. And the one problem they will face is that they will start to receive a lot of private messages, right? And obviously they don't have time to read and reply to each one of them. So there are two solutions to this. One of them is that they can hire a team to manage their social media account for them, but that is very costly. Another solution is having a auto reply system, right? However, auto replies are criticized a lot for being emotionless because obviously you don't want to send a message to someone and the auto reply you, right? So, and that's where our idea came from, is that we analyze a user's past tweets and use a program to imitate, like a parrot, as if the actual person is talking to you. And that makes the auto reply more like a human. Right. Our project will be a web-based application. First, we use the Twitter developer API to mine the tweets and then do a sentiment analysis on those tweets. Then we will use the NLTK and rebuild a fake sentence, basically, and using the concept of natural language generation. Our project is based on Python and JavaScript. The back end is based on the REST API with Flask, and the front end is based on React. And now we'll move on to some NLP techniques we used.
The first technique we're using is sentiment analysis. It is the use of natural language processing, text analysis, computational linguistics, and biometrics to systematically identify, extract, quantify, and study affective states and subjective information. Here are 4 types of sentiment analysis models. The first one is polarity. The second one is feelings and emotions. The third one is urgency. And the last one is intentions. In our project, we apply sentiment analysis on original tweets in order to find seed words that are more relevant. We use polarity as our measurement. Since polarity lies between -1 to 1, we manually set 5 categories based on the polarity of each tweet, namely highly positive, likely positive, neutral, likely negative, and highly negative. The Python library we use is TextBlob, which is based on NLTK, but gives us a convenient way to do sentiment analysis. And it uses lexicon polarity to indicate different sentiments. The sentiment property returns a tuple, polarity and subjectivity. The data we use to train the bot is tweets fetched and saved to a local text file from a target user. Here is an example of data retrieved from British Prime Minister Boris Johnson's Twitter. And these are the examples of sentiment analysis on the gathered tweets. And Kechen will talk about Markov chain.
Another NLP techniques we use in our project to build the bot is Markov chain. A Markov chain is a type of Markov process that has either a discrete state space or a discrete index set. A Markov process is a stochastic process that satisfies the Markov property. In simpler terms, it is a process for which predictions can be made regarding future outcomes based solely on its present state, and most importantly, such predictions are just as good as the ones that could be made knowing the process for history. In other words, conditional on the present state of system. Its future and past state are independent. We can use springtime weather as an example. As is shown in the picture and table, there are three possible conditions: nice, rainy, and snowy. In this example, if the seed word is nice and in Markov chain the next probability of rain is 75%, while the probability of snow is 25%. So we can predict that the word rain should be more likely to generate after nice. Markov chains have found applications in many areas such as signal processing, information theory, and text generation. Li Chen will tell you more about the related studies of our project.
All right, so one of the related studies we found pretty interesting is a story generation using the Markov chain Monte Carlo method. First, they start off by using the Metropolis Hastings algorithm to generate a probability distribution. Then this distribution is used in random sampling, and it's learned by recurrent neural network, RNN. The data they get is from a set of movie plots they found on Wikipedia, and then finally generate stories using the Markov chain Monte Carlo sampling. They were able to get around 85% accuracy to a certain story criteria. So if you want a horror story, if you want a fiction story, it can be generated. So if you are interested, you can look up this paper. Anyways, we'll move on to a demo now.
On the backend side, we need to open api.py. On the front-end side, we use console and npm start to execute package.json. After that, it will open up a new page. Now I'll show you how to customize an imitation. First, we input the username. Then we specify the maximum number of words generated by bot each time. Lastly, we can input some seed words to specify the topic of our bot's tweets. After we push the submit button, the program will first retrieve tweets and save to a text file, and then use to feed the Markov model. And it will take some time. And it seems it still needs some time to finish. And here is the sentence generated by the bot. The new one will allow us to generate another sentence on our settings, and it may generate the same sentence. And if you do not want to specify a user, you can use random imitation. It will generate sentences based on current and past training data. And here we did a comparison on outcomes between using irrelevant seed words and relevant seed words. The first username is UK Prime Minister Boris Johnson's Twitter account. First, we input some irrelevant seed words like game, handsome, and film. For the first result, St. George's Day is a Christian holiday, but here it combines with a congratulation to the Jewish people. And for the second result, encouraging people to vote while wishing a happy holiday just seems weird, unless you have to vote on that day. By using more relevant seed words, we can actually generate some similar tweets. And here are some examples. And the second username is US President Joe Biden's personal Twitter account. First, we input some irrelevant seed words like Mexico, space, and film. Here we use Mexico because his tweets we gathered mainly focus on the US. For the first result, the logic between each part isn't consistent. And for the second result, the first part and the second part seems contradictory. Then, by using relevant seed words, we can get some similar tweets. And here are some examples. And I have to mention that using relevant seed words do not guarantee an accurate imitation every time because of the nature of Markov chain model. And we've encountered two challenges. The first one is emoji removal. When people tweet something, they tend to add emojis in their sentences to help express their emotion. Although it's useful for sentiment analysis, it will cause the Unicode decode error when feeding data to the Markov model from local text file. The solution is to use built-in function from Python library emoji to remove all emojis in tweets before saving to the local file. The second one is lack of data. Some Twitter users have tweeted few tweets that are not sufficient to train our bot. The solution is use Twitter accounts that have more tweets as target account. So for the future works, the first one is periodically post. When the bot has completed the imitation learning of an account, we can set it to periodically post related topics on Twitter. The second one is monitor Twitter for specific topic. We can specify a target string, which the bot will then use to track what happens on Twitter. Then we can use the bot to auto-reply with some target string and keywords, analyze the public sentiment on the specific topics. And that's all. Thank you.